Ladies and gentlemen, let me welcome you at a webinar which is dedicated to I-SEAMORE project and the role of Primoco UAV in it. Let's start with the introduction of Primoco company. Primoco is a Czech Republic company which was founded 10 years ago with an aim to build a UAV according to aviation and industry standards. That means that the ambition of the company was to build a UAV which might be used as freely as you can imagine are the manned aircraft used right now, which means without any restrictions typical for the UAVs, which is flying only over unpopulated area or segregated airspace. The company was founded in 2015 and the maiden flight of the Primoco 150 model, which is the one which is involved in the I-SEAMORE project, happened 1 year ago in 2016. In 2017, the company started with the first deliveries to a real customer, and since then more than 200 UAVs were built in Prague. In 2018, the company entered stock market at the Prague Stock Exchange and became a publicly traded company. And based on that step, it also expanded its capabilities by buying own test airfield in the Czech Republic, which is quite a unique feature for a UAV company. In 2020, the company was certified according to ISO 9001, and then a year later it was awarded with a Design and Production Organization approval according to European Military Airworthiness Regulation 21, so-called MR 21. A year later, in 2022, the company also achieved to be recognized as a LUC holder. LUC means Light Unmanned UAS Operator Certificate, allowing it to fly also with the civilian registered planes in the whole European Union based on the cross-border application. In 2024, the company jumped up in the stock exchange market to a primary market, and in 2025, a huge breakthrough happened because the company became the first one in the European Union to get the type certificate according to military standard 4703 standard, and also to achieve SAIL 3 safety level for the civilian operation, which means that the UAV can fly over populated areas. This would be about Primoco company itself, and it's one of the participants in the I-SEAMORE project, where it contributes mainly in providing the UAV as a platform for developing and testing other capabilities and features of the project, and also it provides integration services for the UAV and other activities. Primoco is represented in the I-SEAMORE project by two entities. One is the mother company called Primoco UAV SE, which is the Design and Production Organization, and the second entity is the Primoco UAV Defense, which is service organization responsible, among other activities, for the export approvals. And because the UAV which is involved in the project is considered as a dual-use item, then it was necessary to involve the other company, which is 100% subsidiary of the mother company. So it's basically two entities affiliated completely with the same VAT number and working as affiliated entities. The Primoco contribution to the I-SEAMORE project lies in multiple layers, and Primoco entities are involved in multiple work packages. There are three major work packages or work tasks for the project. One of them is the improvement of the power system. Primoco UAV model 150, which is the UAV involved in the project, is powered by a unique 4-stroke 4-cylinder engine, which still had some design backups for improvement. And within this project, the engine was modified in terms of using a different software mapping of the engine, different configuration, including oxygen sensor, in order to reduce the fuel consumption, increase the efficiency of the fuel burning, and also increase the or decrease the ecological footprint of that engine. That task involved testing of the engine on a test bench with several configurations, and then even involved flight verification of the performance. So far, the flight verification happened at the company airport in Czech Republic, and also during the first project real flights in Portugal, when the plane was flying from the Air Force base in Beja to the coast where the activity was performed. This task was finished in the hardware and software modification stage and is obviously subject to evaluation within the remaining processes of the consortium. Another activity was a work package dedicated to verification of the Galileo and namely EGNOS navigation system as a system designed to increase the position precision. That task, no matter it was founded and laid down several years ago, is actually very modern and very needed right now because, as we see in Ukraine and some countries close to Russia, the jamming of the GNSS constellation starts to be omnipresent, and obviously the increase in the accuracy of the unmanned aerial vehicles is one of the topics right now which are discussed by every UAV manufacturer. This project involved integration of the EGNOS receiver in a way which allowed to test the precision of the EGNOS navigational system and compare it with other navigational constellations to be sure that the UAV can use EGNOS as a primary navigational system. Even this task was, in terms of hardware, software and flight testing, already performed, and the flight activity either in Czech Republic or in Portugal within the last flight of the project actually confirmed that EGNOS can be used for the navigation precision quite efficiently. Third task is integration of a new sensor, namely the SIGINT system, Signal Intelligence Equipment, which is provided by a Portuguese company, Inov. In this area, the sensor was already integrated and flight tested, so far primarily in the Czech Republic because some adjustments were needed. SIGINT is a sensor which can be used for detection of the human activity in the radio frequency spectra on a long range, regardless of the visible conditions. There are very few SIGINT systems on the UAVs right now because they require quite heavy customization of the UAV, not only in terms of physical adaptability for carrying the sensor, but also in terms of radio frequency, emission control, and electromagnetic compatibility, and so on. So this task took probably longest time from all the task Primoco was involved. And other work packages include Primoco share in various content, starting with the activities related to Kafka system development, so the Primoco UAV can fly and provide and feed directly the I-SEAMORE ecosystem with data in a readable format, up to let's say propagation and advertisement of the common activities within the project. Now let's talk about UAV capabilities for maritime surveillance. The UAV is obviously a valuable asset for maritime surveillance because it comes with relatively long range capability, low observability, and also long endurance compared to maritime aircraft. And what's most important, it can be operated for a fragment of cost compared to a manned aircraft. The Primoco 150, as the major part of the UAV capability in the project, can fly up to 15 hours depending on the payload configuration. Typical mission time is 8 to 10 hours with some reserves. So it can fly and scan thousands of square kilometers of the naval environment per every flight. And obviously it can do it in very bad weather conditions, namely concerning the visibility. The visibility itself is not a prerequisite for the ability to fly or perform the mission. The sensors the Primoco 150 can carry, there is a wide variety of sensors, starting with the electro-optical camera through the multispectral imagers up to radio frequency based systems. For the I-SEAMORE project, we are using only the electro-optical camera and the SIGINT. I believe that they represent, in terms of principle of their activity, majority of other sensors. So should those two work as an example, the others will work as well. Electro-optical camera, as we use it, is composed of a day channel with 30 times optical zoom, which allows long-range search and reconnaissance of the vessels, for example, or any activity over the sea. The same camera is equipped with the thermal vision camera working in a medium wave infrared spectra, which means 3 to 5 picometers wavelength. and it allows to detect any object which has a different heat signature than its background. Typically the ships or even the people in the water and so on can be detected by the electro-optical medium wave infrared camera. The camera we are using is installed in a gimbal, which is mechanically stabilized, and it's also equipped with the software stabilization. So as we tested it, even in a maritime environment when flying in Portugal, the image is very stable and allows long-range identification. Typically, type of the ship can be identified on more than 20 kilometers. A very detailed assessment of the ship can be done from 5 to 10 kilometers. All those distances basically allow to the ship to be aware of the UAV presence in the sky. The second sensor we are using is SIGINT. It's a signal intelligence system which is detecting any radio frequency activity in the area. Advantage of that sensor is that it can work very effectively when there is no visible condition situations, typically through the clouds or through the fogs or through the haze, which are quite present at the coastal areas, and obviously are also used as a masking situation by many criminal activities. So it can penetrate the fog, it can penetrate the mist, and it can detect any activity of human which is related to radio frequency spectra. And obviously such device allows very easy classification of the signal, so it can even provide you the identification no matter you cannot see the activity source of the signal. Other sensors work either in the optical sensor spectra or in the radio frequency spectra, and we can also carry potentially multispectral imagers which are working in more infrared wave bands in the same time, and they are blending the image and they are allowing super fast detection of anything on the sea. Then we can carry synthetic aperture radar, including maritime mode target indication capability, which allows long-range detection of any moving target, including classification of the target. Or we can carry other systems which are detecting other radio frequency emissions, such as satellite terminals or push-to-talk radios, radio stations, and so on. But as I said, for this project, for the simplicity and for the demonstration purposes, only the electro-optical camera and the SIGINT systems are being used. SIGINT is a part of the development within this project. So we can carry multiple sensors at once. Typically for some missions we can carry both the electro-optical camera and the SIGINT sensor at once. So we can easily fly and detect the target with one sensor and then check it with the other sensor or vice versa. And we can also provide night flights or bad weather flights when, for example, the electro-optical camera is not able to penetrate the obstructed visibility. All the data from the sensors are live streamed to the ground control station, and through a secured internet can be streamed directly to any other location, like they are in this case to the Kafka system, for further processing of the data depending on where they should go and what should be the counter action. The loitering time of the UAV allows to stay over the target till some interception from the border guard or coast guard comes. So typically when a target is found and is classified as a target, the UAV can loiter over the target and control and monitor the situation till the law enforcement agencies arrive and perform their activity. Now let's talk a little bit about the tactics, about the operational requirements. At first, the UAVs in Europe are governed by the very same regulation which came into force as the European Union Directive number 945/2019 and 947/2019. That actually allows us to perform this project with a Czech registered and Czech produced UAV flying in Portugal and streaming the data to any third country we would like to. That is the tactics for the civilian registered operators, or those operators who are leaning to civilian standards. And that's already a huge achievement, because without that regulation I just mentioned, that would never be possible in such a free way. So this is really a direct result of having a European UAV which can fly within the cross-border rules in any European Union country based on the very same approval in our case, which was issued by the Czech Civil Aviation Authority. In terms of tactics, obviously one of the requirements for the improvement of the engine was to reduce the silent signature. So the idea is that you deploy the UAV in a way that it's not spotted by any opponent on the sea, and it can perform the scanning activities without being detected by anybody sailing on the sea. So it allows to fly in a specific pattern, which can be either pre-programmed or changed during the flight every day, and to gather the data. The more data the UAV selects, the more data can be later analyzed and evaluated in terms of their time sequences and frequency and so on. So the planes, the UAVs should fly on a daily basis in the operational area to gather the data, and they should not be noted by anybody on the sea. The advantage of the UAV is the endurance time and the cost. The endurance time in our case is 8 to 10 hours, typically a mission time. Maximum endurance is 15 hours with light payload. So it allows you to 3 to 4 times exceed, for example, the loitering time of the helicopters, which needs to go to refuel, you need to change the crews and so on. Obviously with the UAV, when the pilot is tired, he can just walk away and hand it over to another pilot. So it gives you quite a lot of operational flexibility. Once the UAV is flying, they should be replaced one by another one, depending on the sectors. So they are going to scan the area, and whatever they identify through the sensors, either the electro-optical or the SIGINT in this case, is distributed directly through the Kafka system to the I-SEAMORE ecosystem, and then there is a decision taken what should be the next step. This overlay, which allows to integrate various objects, various assets, either the UAV or the unmanned submarine or any other asset in the area, is one of the biggest achievements, because for the real operator, for example, the border guard or the coast guard, it really doesn't matter which asset got the intel. The point is to be quick and fast in the decision and the interception process. So it allows to get very quickly the intelligence for either machine learning or human operator evaluation, what should be done next with the data which are gathered, and obviously the low demands in terms of the man hour and in terms of the logistic and so on allows to use the UAV on a daily basis in even the large areas to increase the situational awareness. Since this I-SEAMORE project is based on various assets and they are all integrated into the Kafka system driven management layer, it's fantastic because you can add basically any other asset, a new UAV, new vehicle, new ship or whatever, and it doesn't change the requirements because the interface is already existing and it defines what's needed from the new asset to be able to go into the system. What we tested already is that I-SEAMORE management layer can actually control the UAV in terms of providing it the coordinates where to fly. For example, any other asset discovers something on the sea which is suspicious and you need to have the aerial oversight. So you simply through the system send the coordinates to the UAV and the UAV recalculates its flights to perform the surveillance in the desired area. So this is what we already partially tested and will be subject to the full-scale testing later this year. And since we are only one of the assets and the management layer of the I-SEAMORE ecosystem is not lying in the UAV, it's a very versatile system allowing to expand for any other platform which is desirable. So, conclusions, lesson learned and similar activities. For Primoco, the I-SEAMORE project is a wonderful experience how multiple entities from all over the Europe can cooperate on a single goal. Because at the end of the day, it's about every partner giving his piece for the final result to come. And already when we were flying in Portugal with the first test trials, we were able to achieve some synchronization between the team. Now we believe that flying in Portugal again very soon will be able to demonstrate the full capability of the system, which is absolutely scalable, which is able to cope with the current threats the Europe is facing, and which is fully based on European technologies and European knowledge. And that's something what's not here every day. If I may speak for the UAVs itself, UAV is typically something you associate with countries like US, like China, like Turkey, and so on, and unfortunately not Europe, which is a big threat because, as we see from the last development of the combat activities, UAVs are the decision moment in many modern warfares. So we are very happy that we had a chance to be partners in this project, and we see that this kind of integrated solution able to benefit from the all European regulation, for example, in the UAV, is exactly the way the development should go. So that's what we expect for the future.